मग तुझ्या ह्याच्यातून गुड मॉर्निंग सर.
Good morning, madam. We'll
Yes sir,
start.
you can start the session. Yes sir, yes sir.
Okay. Yesterday we discussed about Emerson Delta V DCS. Just we'll see the plant systems, what type of size of the plant and what type of accessories are required. The systems are used in actually in the plant. So as I yesterday I told Delta V is the product name for the DCS in the Emerson category. Controller name is MD plus, and then it goes always version changes as I told. So there are few systems here on the MD plus controller. One of our plant is a sewage treatment plant, processing plant, training center we have. Then other plants also systems are there. These argon plant, phosphoric acid plant, ammonium nitrophosphatic plant means ammonium nitrophosphate in so ANP plant. In one of the sections we call as a ammonium nitrophosphate is a fertilizers, uh, complex fertilizers. So I'm skipping some slide. This also I'm skipping, but you, as you know, we are talking on DCS. There are various options in the automation PLC, DCS, SCADA, safety system, PC-based control. Uh, we'll discuss it that DCS has always trends are there. Now systems get upgraded fast because of the technology upgradation on the hardware, computer hardware, softwares, and cloud and all. We can we're talking on the remote access. So technology always changes. This is a simple closed loop. But when you see the when the system started. Uh, in the beginning, I mean the 80s, 84 or 82, the architecture was like this. You see the control room, various sections, and analog signal. This is the what conceptually it is shown. This is a controller, and all controllers get network and workstations in the control room. So typically, if you see the DCS architecture in generalized way, this is a control network, which each company has a proprietary name. As I told, Emerson has a high-speed Ethernet. Yokogawa has a VNet. Then Honeywell has something different name. ABB has different. Like this, the fault tolerant Ethernet is a Honeywell name, FT, but it is a Ethernet, dual redundant Ethernet, and these are boxes means these are controllers. If the plant size is, for example, refineries are there where so many controls are required. So you can see these are controllers on this proprietary data highway control network, and they get connected to the workstations, operator stations, engineering stations, from where the engineers and operators and chemical process engineers are operating the plant, or instrumentation engineers are maintaining the plant, configuring the plant. So these are the stations. And one of the controller you can see here, uh, to understand quickly, it is shown that analog inputs, analog outputs, discrete inputs means digital inputs, digital outputs. So there are few examples shown in this slide. Analog inputs means level transmitter, the level inputs, level process parameters through transmitter. Analog inputs, hard analog inputs is coming here. Temperature transmitter, pressure transmitter, even flow transmitter. So these are the type of analog inputs. Suppose somebody asks, you tell me the analog inputs few names. So these are the few names in the analog input category. Analog output also you can see here: level control wall, temperature control wall, or you can have VFD controlled. Nowadays VFDs are there, so VFD controlled. So analog output from the analog output card in the DCS is used for controlling the speed of the motors. Earlier it was not possible, but evolution of the VFD has helped this. Earlier motor has to be controlled either on or off. Then discrete inputs means level switches. These are the HS, means high pressure switches. Then pressure switches. So these are the various discrete inputs. Switch is the inputs. or push buttons, level switch. Like this, inputs are discrete categories, digital inputs. Similarly, discrete outputs are digital outputs, like on-off motor, then solenoid valves, or through switch you are operating something, some walls, safety walls. So these are the discrete outputs. So you can see here PSL means pressure switch, low pressure. Then you can see LSH means level switch, high. LCV means level control wall. So these are the nomenclature description here. But conceptually, this is what DCS is getting interface with the field inputs in the category analog as well as discretes. So this is what, and it is shown on the controller. So this is the what DCS architecture. Here each manufacturer has a different name to the controller, different name to the control network, different name to the workstations, and even for their IO network. So we'll come yesterday we seen high speed Ethernet for this. However, there are systems with dual architecture, uh, with IO network is also introduced. However, here in the Emerson Delta V, there is no IO network introduced. So traditionally, same picture you can see the with the pictorial format. You can see the control wall is output device, transmitters as a analog inputs. So these are the devices connected to the junction box. Yesterday I have shown actual junction box in the field. Uh, and then these were multi-pair cable coming to the marshalling cabinet. Then IO terminations means isolations, for safety of the electronic, safety of the process signal in the field. IO interface cards means analog input, analog output, digital output, thermocouple input, RTD input, serial interface, field bus interface. These are the interfaces cards here. And then it comes to the controller. So finally, here controller process the entire configuration and then come to the workstations. So this is the what in general DCS architecture is. When we switch to the field bus, yesterday we seen one card, field bus card, H1 card in the Emerson Delta V DCS, this H1 card. So when we use H1 card or foundation field bus communication protocol based devices, so these are the foundation field bus based devices, and you can see this is a switch, like a network switch, and this is what we call as a junction box, field bus junction box normally. And you get all devices connected, like you can see the as good as your computer network switch, and through that with a single cable, all from this switch one cable is coming here from this. So you can see here all these devices are digital devices on field bus protocol, and they get a network with a single cable. And you see the uh, cables reductions, as well as you can see here marshalling panel space reduction. So many advantages are there. But operation and maintenance point of view, you can configure these devices, you can maintain these devices, you can calibrate these devices some part through these workstations. Through these, you need not to go to the field side. So that is the advantage of field bus control. So I will take yesterday I was discussing that argon plant, purge gas recovery plant. We have Emerson DCS, and this DCS is also connected to the existing ammonia main control room, where Yokogawa system is there, and you can see the fiber optic cable is used with the converters. So that is what it is shown, converters, signal converters. So yesterday I have shown these slides. The cards which use in the organ plant is shown here. This is ammonia main controller. I'm showing just the network how it is uh, extended. Control network is extended through fiber optic. So these are the fiber optic uh, interfaces, converters, signal converters. So this I have yesterday discussed, but I'm just referring. See, in that organ plant, means PGR means organ. cards use 12 8 channels. AO card 12 8 channels means you, what you have to take understand from this slide, that analog cards with 8 channels means you can connect 8 transmitters, 8 analog inputs. But that type of a 8 means 12 cards. Similarly, output is also 8 card, but digital input cards are high density means 32 channels. So sometimes question may ask size of the cards, digital input cards. So you can mention that card is having 32 channels to understand whether how much you know about the DCS hardware. Digital output cards here to use the 32 channel same. So there are, in this plant there are closed loops is a 48, and in that this is very important because of closed loop these AIOs are used there, and because of redundancy, the number of cards are increased. So for one closed loops, one channel. So suppose you are using 8 into 8 means uh, 8 means you say minimum 6 cards are required here, right? But there are 12 means if they are redundant cards. So you understand 48 means one loop require one analog input channel and one analog output channel. So that way the card size is defined, or when you are selecting the size of the system, that time you are taking care okay, how many closed loops, and furthermore 10 to 15% expansion. So I'm taking the example of another plant, that is the sewage treatment plant. STP is a short form, sewage treatment plant, where Emerson Delta V DCS is there. There you can see two workstations. One is for engineering, which can be used as operator, and another is exclusively operator. The difference between two, as I yesterday I was explaining, what is the difference between engineering station and operator? Hardware wise, almost both are same. Only difference is that engineering station has extra configuration software is have to be purchased with required licenses, and that is installed on this. And that passwords or access control is with the engineering, with the instrumentation departments. While here operators personalities, what we call access is there, and operator related to operation, graphics, set point controls, alarm control, then printing options, and all it is there on the operator sides related to operator uh, of, job role or functionality, we can say. So in that system you can see there are two switches, primary and secondary. And here you can see the system carrier, where power supply controller, power supply control, so two controllers are there. They are having serial interface with the PLC. You can see the serial card modbus with a this is, they have earlier Mitsubishi PLC, and this Mitsubishi PLC is connected on the serial bus. AI card is there, AI ADU, DIDU, like this the cards are there. And they have field bus installations earlier, and through the H1 card they use uh, field bus uh, connectivity with field bus transmitters, pressure transmitter, smart wall, like this is H1 connector. So you can see a H1 here. Mm. And these are blank slot means therefore any expansion future is there, you can use these slots. However, in this carrier only digital output card and one H1 card. So this is the architecture, size of the sewage treatment plant, uh, DCS. So some pictures of their plants you can see, as I explained the what is the system, but you see the actual uh, screenshots of the installations. You can see here power supply controller. This is a Emerson DCS. So you can see these are standard Delta V logos. Here logos are there on each card. And you can see below the controller two wires are there, means these are network wire. And why two? One is a primary high speed ethernet cable, and secondary another. Only you can see the color is there here at cap, connector cap. So you can identify primary and secondary cable. Similarly, for secondary controller here, this is a, primary power supply, primary controller, primary secondary power supply, secondary controller, and you can see here network cables. So these are normal network cables which we use in our computer. So it is a very for as far as the connection is there, very user friendly. And you see here, this is a 8 wide carrier where 8 slots are there of whatever required AI, ODI, whichever required in that plant. And this carrier is extended through this connector to the another 8 wide carrier. So this is another 8 wide carrier. So this way, if your plant size is uh, more and more IOs are required, you can extend this like this. Again, you can extend also like this. So this is what another 8 wide carrier, and you can see here it is extended from here with this connector. You can see this way it is looped like this, and you have more 8 IO cards you can put it here. And you see these are wires coming from the your marshalling cabinet and connected to the uh, as per your drawing, connected to the individual cards like this AIO. This is a terminal strip. You can see here. So this is what actual DCS in the plant. Same picture is shown here for this is a picture for this part. You can see this part is here, and above this you can see here these are power supplies for that carriers. 24 volt DC is required for carrier, and above here you can see these cables for power supply to the cards. It's, as I told, 5 volt, 9 volt, 12 depend on the controller version, but 5 volt we it's a 5 volt. So this is the what this is what system. Mm, mm. So actually this is the system. Okay. You can see here. Here also it is mentioned the cables are there. Power supply cables on top. This 24 volt DC power is redundant. Here also redundant power is there. So it is on the back plane of the carriers. So this is what the system is. So what you can see in the picture, uh, power connections, network connections, and IO connections, and how it is extended in the Delta V system. IO carriers, IO capacity, how is extended. So this is what shown in these pictures, various pictures. You can see here various cards, termination, because DIDO some different color cables, AIO some different colors, with the ferrules showing the uh, this ferrules. You understand, for identifying from which uh, area it is coming, from which devices it is coming. So this is because these are coming from marshalling cabinet. So marshalling cabinet big terminal strip is there. There you will identify this termination is from marshalling cabinet. Ah, so I think this is what a very important picture for you. This I have just before that I have shown organ plan. Now here AI cards are 11, AO cards are 3 only. So number of closed loops are less here. And then all digital inputs are controlled using PLC. Here DIDOs are not there. PLC is used for all digital input output to control, and there are only 24 closed loops. Now I'm coming to another system which is in the training institute, which I have shown. There we have two workstations, primary, secondary switch, and you see the power supply control. No redundancy in the training system, so only power supply and controller. AI card, AO card, DI card, all of our cards are there to understand the students, the function of each card, how it looks like, how it is configured, how it is wired. So we have in the training institute all types of cards. AI card, AO card, DI card, DO card, RTD, thermocouple, H1. Yesterday we have shown the serial cards. These are the field signals. So this is actual picture of the training institute system. These are workstations you see. Out of this, one is the engineering. This is engineering plus operator. This is why, however, this is only operator station softwares, and this is the auxiliary panel from where you can simulate some control loop. So you can use this and digital inputs switches. Use this digital input like a selector switch, push button. These are selectors. Digital inputs. Digital output is your indicators. Digital output is your alarm and setter. Analog outputs are here on the analog display, analog loop calibrator. So you can see here analog outputs also. Even the plant is there, but still you can have some controls from here. So this is the actual system in the training institute. You see here actual photographs. Powers, as I told, we don't have redundancy. We have redundancy for the power supply only. So power supply redundant, controller is the single, no redundancy for a controller. And these are 8 cards. Se- Serial, yes. Serial is for, as I told, PLCs and analyzer. H1 for foundation field bus. And you see these other cards. This is a thermocouple, RTD, DI, DO, this is a DO, this is a DI, this is a AO, this is AI cards, and this is terminations. Mm. So when we see the closed loop, how it is working, we have seen in the plant there are various closed loops. So you can see here closed loops, transmitter, and as I told, from transmitter wires are coming to the JBs in the field, and from the JB it is coming to the marshalling cabinet in the control room, and then it is a loop like this. So yesterday we have seen this. So I'm just going fast. So this is what one of the architecture in the refinery. This picture is for refinery DCS architecture. You see here some sections identified here: crude unit 1, naphtha stabilizer, crude unit 2, crude unit 3, like this. These are the refinery processes. So these are the process areas in the refinery, and you see here how many RTDs, how many thermocouple, 18 RTDs, 8 thermocouples, 8 discrete inputs. So in this section, this is what the requirements. One heart output, 8 heart on this card, 8 heart, sorry, inputs, 1 heart outputs, 9 foundation field bus segments, 20 transmitters, 19 control valves, 10 switches on off. So this is the what in this section. Similarly, in this section, there are different configuration: 9 thermocouples, 1 discrete input, 2 hard inputs, like this. 2 foundation field bus segments, and this third unit number 2, grid unit 2, again this. So what you have to understand, whether whatever type of a plant, as far as the instrumentation engineer, you can understand here RTD, thermocouple, digital input means discrete input, discrete outputs, hard output, filbus inputs, sorry, filbus devices, control valves, on off switches, are these types of devices are to be connected to the DCS, and that type of cards are required. So last unit is a crude unit 2 is a heater unit. So heater means only discrete input and discrete output, heater control. There is no analog signal here. And you see the number of workstations, and this is the Delta V Ethernet LAN, that is a high speed Ethernet. And on this, you can see the workstations, control room, 3 dual monitors. So you can see dual monitors the system. Then engineering office for instrumentation engineering, these 2 workstations. Then bar dock. This is operator station, some remote area. Bar dock is there. So they have different options. So on the same network, you can see all these plants are there. And control room is a single. Earlier, I have shown argon plant separate, ammonia plant separate, sewage water treatment plant separate system. However, here you can see you can have a plant wide, means plant wave open architecture also. That type of a capacity available expansion is available in system. But however, uh, in the refinery it is done like this. However, fertilizer plants, there are separate plants, so separate processes, separate control rooms are maintained. Refinery normally this type of architecture is maintained, where one control big control room size wise, and all the sections like crude one like naphtha and all together they are in the one control room area, all workstations, all control hardwares like marshalling cabinets, IO cabinets system in one locations are it is there. So this is what Emerson has a plant web. They call plant web open field based architecture. That is on dual line, means that is fiber optic because the location are remote, and this is high speed Ethernet. Mm. So this is what I have already discussed and shown you. This also I have shown. I'm not taking time on this. This is also shown. Some pictures are already shown to you. This was the not there, but you can say I was always talking about two wide power and control carrier. Means this is the slots you can say, and on these slots you are putting, you are inserting cards here, power supply and control, and this is the what termination for your power power supplies. And in this slot you can see 8 wide carrier, few slots are shown blank. Here your terminations are there, slots are there, and screw is there, and your card goes inside here. And this is the what termination for 24-volt power supply to the card. So this card how it is inserted, that picture is shown. So that is what about the system. So this way you can insert the controller card inside. So it is easy for maintenance, easy for replacing the card. That is what it is shown. And the back plane where the your carriers are there, that is called a dean rail. This is rail is there, that is called as per instrumentation terminology standardized nomenclature. It is called a dean rail, like we call carrier for this. Same thing, these names are came. So this I have shown. This I have shown. This is also covered. This only I will explain. So power supply, how it this was not covered. So I will explain in detail. As because in the DCS, maintenance is very important, and power supply is the key area where you always maintain the power supply. You have to test the power supplies, and this power supply has to be very stable and regulated. So you can see here power supply, which is we normally call as a bulk power supply, uh, and you see here bulk power supply. Main power is coming from here, from your plant distribution section, and as you neutral ground and phase is here, three wires are there, and these you can see here how redundancy is maintained. So two bulk power supplies means here bulk power supply means you will get here 12 volt also, 9 volt also, 5 volt also, and based on your requirement you have to uh, use that power. Like Applab has power supply, like many other companies also giving, but Applab, you know, in the laboratories, this name is very uh, reputed in this area, UPS and power supplies. So you can see three phase supplies coming here. Then phase neutral ground is there, and same supply is given to the another bulk power supply. This is the redundancy. And this DC supply from here 12 volt goes to the controller, and this 12 to 4 volt supply goes to the power supply, these cards. So these are the this way it is connected. You see here, this is very important. This is IO carrier, and for that IO carrier the power is 24 volt DC. From here it's coming like this. So this is a power and controller redundancy, controller redundancy here to one this and this controller redundant. Simplex controller means there is no redundancy with you can simplex. Redundant link is there, but no card is there. Controller redundancy means you have two power sub this power supply control powers like this way. This is active controller where you can get indication here. This is a standby controller. Then hard AI inputs are here. Hard protocol logo is there. This, as I told, size of the cards. Series 2 EVO, 8 channel, 420 milliamp EVO. Intrinsic SIP EVO also there. Intrinsic SIP 8 channel heart is also there. So if you see the any hard input card, these are the standard specification. Number of channels, whether isolation, what type of isolation is there. Nominal signal range 4 to 20 milliampere, full signal range 1 to 23 milliampere with the over range checking. Local bus current 12 volt DC nominal per card, 100 120 milliampere typically. Maximum is 150 milliampere each card consumes. So accordingly, these are the data required for uh, sizing your power supplies because it should not load it. Accuracy over temperature range, resolutions, repeatability, resolution in terms of the AI cards, A to D converters are there. Roll off frequencies, calibration not required. Communication is a hard scan time. That is a standard. And fuse is inserted 2 amperes inside the card. So these are the what yesterday I have shown you the card electronics, fuse, A to D converters, and isolations and the terminal strips. So this also I have shown yesterday. This is IO cards types DI, AO cards. So this yesterday I have covered this, so I'm skipping fast with this. RTD we have discussed, thermocouple also yesterday we have discussed. So in the delta V communication interface, foundation field bus interface, as we have, this is a detail about the various communications like serial bus and foundation field bus. So foundation field bus interface series 1 and 2 normally this is the first series came 1 and then series 2 card. So two ports in the card they have and maximum 16 devices per port. With a 1900 meters device net series 2 means series 2 you will get a distance maximum 1000 means 2000 meters for example you can expand. So what you have to understand, so one H1 card with the two ports and per port 16 devices, so maximum 32 devices you can connect on the one H1 card, Filbus card. That is what I want to tell you. You can with another protocols, Profibus DP, Azibus. So these also cards are available with the Emerson Delta V DCS. Means you can have a interface on backplane with H1 card, Azibus card, Profibus DP card, then device net cards, uh, conventional RS-232 protocols, Modbus cards. So that is possible. That is what I am telling you. So this is one card shown is a Modbus card. Modbus power card, how it is integrated with the DCS that is shown. You can have a PLC networks, or you can have Modbus master, Modbus slave, data highway plus. ABRS 485. That also Modbus protocol RS485 also you can interface on this. So you can have PLC interface with the various options. That is what it is shown with the different protocols. S- There is also requirement as I have shown one picture that immersion system with Yokogawa, immersion system with Honeywell. So in this picture slide, you can see how Honeywell system is interface with immersion DCS. So you in one of the plant you can see here Honeywell DCS is there, and one of the plant there is a Delta V DCS. You can see here identified is a Delta V color and here Honeywell cards colors, and you can see the devices as I told. Transmitters are almost same here, but on serial interface you can see the card serial interface card of the Honeywell DCS and serial interface card on the sorry, Delta Emerson DCS. You can connect here serially. So Honeywell controller, maybe these are old series PM, APM, HPM. This and now they have series C controllers, C200, C300 controllers in the Honeywell DCS, and similarly MD plus here as a controller in the Emerson DCS, so they can be connected. Similarly, you can see here even your data on OPC server, you can connect OPC server of Honeywell and OPC server of the means you can share the plant data from the servers also, and for that OPC protocols are used. That is what it is shown. As a controller to controller, you can share the data through this Modbus. However, for your optimization, simulation, energy related, or you have suppose related to the compliances related to the pollution control and all. So the data is here of this plant, which you can share here. Okay. So this way, Delta V OPC interface with a Honeywell OPC. You can see here. These are the controllers of. This is a Honeywell controller. This is a Emerson controller. These are workstations. This is a workstation of Honeywell, and you see here through this server, OPC server, Honeywell server, Delta V OPC server, and they get connected to on the normal Ethernet. So Delta V domain, Honeywell domain. So this is OPC connectivity for process data uh, used for your compliances and other application like optimizations and all. Mm. So Delta V Connect, Delta V migration solution for Honeywell systems. So there are advancements are coming. You can see here. Uh, these are the control networks, and through this you can see here Honeywell local control network here getting connected to the Delta V systems here on normal Ethernet. This is a Delta V connector controller. However, this is a Honeywell controllers on directly on the Ethernet. This is the Ethernet. You can see Honeywell system here with Honeywell controllers, Honeywell workstations, and these are the Ethernet switches. So that it is connected. Redundant interface. Mm. Oh, so we will go ahead. This I have shown yesterday analyzer on the Modbus. This is a ammonia system with ammonia plant. We have controllers and Honeywell DCS here. They get connected here. So now I will show some accessories related to the foundation filters here. This is the foundation filter H1 card, and I was always talking the picture of H1 card. This is the what power supply. Now it is not required. The new cards are coming with a built-in power, but this was the power supply earlier card. First series, it was required power supply external to be mixed with this. And this is the junction box, what we call like looks like switch and all. So this is a P&F company also. Pepperl and Fuchs. This is a German company, and they manufactures also. There are other MTL and other companies, Cisco's and all, they do have it, but industry grade. Uh, we This is one of the reputed field bus junction box. Looks like a switch. Here you can see the you have to connected the devices on these cables like this. So this is the junction box I have shown in this, and these are the filter devices. And then, as I told, this was earlier required, now not required. This power supply straight away to goes to the card. And the what you have to understand on this terminology: card, foundation base card, foundation base junction box, and the cable names. This cable is called trunk cable, main cable, trunk cable, and this from junction box to the devices, the cable is called spur. So this name has came from the foundation Philbus organizations when they invented, launched this protocol. So FF junction box, these are FF devices, controller positioner, Samsung positioner, Emerson transmitter. This is the card, H1 card. And in this, this is the logo of foundation Philbus. Like heart has a logo. So this is the logo of this. So this is the what Pepperell and Fuchs Foundation Philbus junction box. So connections for spurs and connections for trunk cable. So your always trunk cables are connected here. Spur cable connectors are there, and you see here these are the screws where fastening options for cable connectors. So you have a layout also. Spur one, spur two means this way you can connect devices. 10 plus, you can see here 11 minus, and this is the common ground. 13, 14, 15 plus minus. So numbering is here with the plus minus identification. So you have to properly connect this plus minus and earthing. So you'll get four inputs. This connector you will get six inputs connector. You get eight inputs. So based on your requirement, you can purchase. So this is the actual picture. This is what their terminologies and actually in their catalog picture. So you can mount it on wall, or we have mounted like this. Connection for spur, connection for trunk, fastening means cables you can rotate like this. Fastening cable glands, when these cables are through gland, it is going to be industry grade input and output cable. So earthing clamp, side switch field bus terminations. If you can terminate it here, if you don't have extensions, you terminate here through normally any network cable network you have to terminate with the RC combination. So here you are a terminator. Mm. So H1 fieldbus devices are shown here. Mm. So these are foundation fieldbus devices here. This is a multi-variable with a single pipe intrusion mass flow meter, radar, control wall, transmitter, and eight means you have this junction 8 DI like this. You have a multiplexer type of electronics is there. Through this you can connect also. This is a heart logo. Mm. Workstations, controllers, heart, H1, Azibus, as I told, device net, Profibus, all types of protocols devices you can connect. 100 now it is more also gigabyte. So any DCS you can see when you have to compare what this slide is showing. If you have many options, reputed companies, Rosemount is now Emerson. So Honeywell, Ecogawa, Moore is also with Siemens. Model number always you can say they like Delta V is a model number. Yokogawa has a Center V now. Here you have a series C controller means a C300 controller. Controller name HPM means here MD plus. Here now the name has changed. Here also name has changed. Operator station also name has changed. But when you are comparing, then comparing this are the your criteria. Model number, controller, operator engineering station name, operator engineering station hardware. Presently, Dell category, latest speed, memory, and operating system. Softwares like that time it was when Windows NT was the very popular, but now latest Windows version is used with the server configuration, server grade. Plant communications, as I told, Ethernet or high speed Ethernet or VNet or FT, fault tolerant Ethernet, like this name has came. But field communication means input output card communications. What the name of the protocol? Here earlier was UCN name, but now they have IONet, RIO bus also change, node bus. Like this name has changed. Here they say field bus, and there more has module bus. So this is overall about your uh, actual plant, this Emerson Delta V DCS. Now we are going further with we'll see now how to configure. Now you have seen how it loops are wired. Now we'll see how loops are configured. How loops are configured. Suppose how graphics are developed. Because I have explained you the hardware, what softwares are required, what is the functionality of that. Now we'll see actually when we are working with that workstation, how what are the steps and how it is working in the Delta V DCS. So Emerson Delta V DCS configuration and graphic developments. So I am explaining the steps for a configuration. So when you are in front of the workstation, first you have to explore Delta V software. There will be the software will be installed. So you have a Delta V software there with the name. So explore it. So first step is exploration. Then creating a control module. Means suppose you have to create a PID module. So creating is the second step. Then once you created a control module, then third step is assigning control module to the node. Means suppose you have this control module, for example, LIC 103 level indicating controller PID module, and you have a given number 103. Say I'm just taking one example. So, but this control module, which controller will be assigned? Suppose there are two controllers in your plant. So you have to assign controller to the node. So there, here you are specifying that node. Then downloading control module in the controller. In that node means down the controller. There are options for downloading control module. So creating module, assigning module, then downloading module. Then once you are downloaded and there is no error, successful download message has come. Then you go online mode for of the module. Check online. Then six steps creating a faceplate of module. Now you have a graphic options there. You can see your module faceplate. Actually, you need not to go in the program mode. Just you graphically you can see your values, set points, or detail about your PID module. So creating faceplate module in this, then setting up properties of the control module. There you have to set the properties of the control module. Means, as I told, range of your input, range of your outputs, units, everything you have to specify, because in that uh, module gives so many options, but required options you can fill it. Then you have to open the space plate on a main screen, means on the graphic screen. So far you are working on the, as I told, engineering software which was required for this in the engineering station. Through this you have created. Now you see this space plate on the main screen, means your operator graphic screen. And then in the graphic screen, open detailed display in the module on main screen. So you can see here on main screen, detailed display, whatever you have downloaded or specified, configured the parameters, that you can see. And in detailed display of module, everything operator can see. Means in process people, process staff can see detail of that particular. For example, I explained LCV 101. So level control loop, whatever it is there, so that can be displayed there. So how it is explored? This is the one screen of exploring delta V. You can see here. You see here normal your PC screen. Here you can see RCF, and you can see RCF dash 8 dash 4. And here library is another folder. The system configuration, under the system setup is there. Then control strategy and physical network. So you, when drop down this, you can see here in the physical networks, you can see here, when you drop down this decommission nodes, then you can see here control networks. And in the control networks, again when you see, drop down details, then controller one is shown, then another control is there. DVINST and OPS is the operator station, and this is the engineering station. These are names given. You can change the names. So this is the your engineering station. This is your operator station. So in the Explorer screen, there are some indications shown. If you see here, operator station is not connected. Maybe some problem in cabling, or you have not started it. Delta V engineering means instrumentation or engineering station you have connected. Your controller is showing some question marks, and this triangle with question marks, blue triangle, means something is error is showing, and same error is carried here. You here also, then same error, this entire network showing error. Means on the error is on the controller, which is shown on your explorer here on the physical network. So you will understand, when you are exploring, some parameter has to be either mismatching or not properly downloaded in the controller. So when you are exploring, you are getting entire screens like this, and you'll come to know what is, where is the problem. Now IO cards, serial card, and two ports. So here one example is taken for one of the IO card. Now when you are in the this exploring screen, RCF, as I told you, the system configuration, you are in the setup. Then in the setup, sorry, in the system configuration, you are in the physical network. And in the physical network, this is the one node, but as another physical network is a Ethernet network, that is a control network. And under the control network, you have a controller. And when you drop down on the controller, on the controller, you will get assigned modules, as well as you will get a physical IOs here. And in this IOs, when you click on this plus button, you will get how many cards are there on this controller. Actual physical cards will be shown. So on this controller you can see CO1, card 1, card 2, card 3, card 4, card 5, card 6, card 7, and card 8. There are 8 cards. However, now on the 8 card is showing a triangle, means some configuration mismatch is there. And when you click on this plus of this card 8, you will say there are two ports, because this card is card 8 is in your system is your H1 card or your serial card. So here it is a serial card, but serial card means a Modbus card, and this card has a two ports, port 1 and port 2. So you can see you have something connected on port 1 here, and this is showing error. So this you can see, you are easy to identify where your problem exists. Even though this triangle is here, which is on the physical network, which is on the controller, which is on IOs, which is here also, and then you identify my this card has some configuration mismatch. Not all the others, there is no error. So you can identify this, and you can uh, remove this fault uh, here. Or you can check what is the wire, either wires are loose or not properly, means cross, you have to cross check all this. And then it is related to your wiring also, and it is related to your software configuration also, right? So this way your card is shown, right? Mm. Now so earlier, this is what how you check your system in the software. Physically I have shown. Now you can see on the software also how your system and where your cards are there. It is reflected here on the software, engineering software, that is called Delta V Explorer. They call it Explorer screen. So you see here the screen here, type of database, system configuration, libraries in the database. So this is what the uh, you can see the hardware actually installed in the system. You can check it here. Now how to create a control module, as a this is take an example. We have to create one PID loop. So what you have to do, creating control module, you will get a screen, control studio. The software name is a control studio in the this Delta V. So you are in the control studio screen. You see the file, edit, view, entire layout, entire thing is there. And this screen is you can see divided in many areas. This is one area. This is another blank working area. This is also help is here. Alarm configuration is here. So you see here the screen is divided in 1, 2, 3, 4, 5, 6 areas. Now when you are creating the any module, so you have to mention here, this is a control studio software. So you can say alarm, miscellaneous, tuning parameters, and operating parameters also here mentioned. And special items like input parameters, internal wire, internal write parameters, means this is for checking purpose, output parameter, physical parameter. So special items are here, and you have to, what you have to do, I will show you. These items you have to take it here on this working area and just wire it. So there are various function blocks are available: IO block, PID block, logic block, analog control blocks, and you can get it here from here. So you see here special items here. Now you just take one example. You are taking one digital input module. So what you have done, you have selected digital input from here. You have just select here and bring it here. So that you have done. And then what you have done, this digital input, you can see digital input, controller 1, IO 1, card 8, port 1, device tag, And this is a register value, means this is what PLC interface PLC has been connected to the serial interface card to this DCS controller, this controller. So this is the what entire tag showing the from where this digital input is coming now to this card. This is card. Now I'm going ahead. Select the digital input to and assign IO as shown. Now this digital input is the assign IO. Just you right click on this, then to actual wired signal you have to assign it here. Here assign IO to signal tag here like this. So everything is available on the screen. Just once you understood how to select it, how to drag it, how to connect it, how to download it, how to run it or online mode. So now actual parameter path, how it is given means actual wiring you have done from the JB to marshalling cabinet to the card, but software don't know. So how to link that, so that are there are the different screens are here. You can see here how the parameter properties, physical network, control network. Just you have clicked the control network here. You are on the explorer, right? And looking in the system configuration, physical network, control network. Under the control network you have selected controller, right?
Hello, sir.
Under the controller, ha, yes,
Hello. How much time is
ha,
required
hello.
to how much time is required to wind up?
Just two maximum 5 minutes.
Okay, okay, sir. You continue.
So you see here the multiple screens are showing how you are going ahead with this controller. IO cards, IO you select. Under the IO, you know there are 8 cards. 8 cards are shown. So this way the each one you have to select. So this way system gives you link to the actual where your input is going to be processed. So then finally your tag, actually field tag, field instrument tag. A controller has these field tags, and you see here this controller there are field tags, card 3, channel 10, like this. Now you just take example, I will take this example. Controller 1 means a single controller, card 3 and channel 5. So you know the card 3 is your digital input card, and channel 5 is here, and just you take this and connect to this, and this is a parameter value. So you have connected here controller properties here like this. So now this way you have assigned this. Now you have taken another in digital output module from here. Here you have to select from digital discrete output here. You see a discrete output, and just here click it here and bring it here. That's all. So you have done this now. Now next step you assign it to digital output card card 4, card 4 digital output like this. Then you just go ahead. So you have wired this like this. Yes, you have what you have done. You want output of this card digital input going to the output of this digital input goes to the input of digital output. So this is a switch input actually, and this is a, for example, lamp indicator. So you wire it, just put it your pointer and just bring it, and then once you assign this, you see here your tag and all. Now this is the what screen for assign to node and download. So this is the screen coming here, and you just assign and download. So moment you click on this, automatic first it will assign and then downloading starts. So go to online mode. Once you are downloaded and there is no error, you see here on the this control studio. This is healthy one. This your output digital input status switch is on. So one is here, and finally this digital output is showing one here, means actually you will see the lamp is on in the field or on the panel. So this is final output. So go to online mode to see the results. So results are here, and these results are you can check. For analog, selecting output block, analog output block you take from here, select here, bring it to this area, assign this to the tag, right? This is your analog output, and you are assigning to the tag. So like this, you see here, physical network, controller, IOs, and you are just here. So you are assigned analog output here like this, and then finally you have to download it. So downloading processing start then. Now to see the, you will see this AI. This is what your faceplate, and then you creating faceplate here. Just click it here. This is what it is called a faceplate. Setting properties of a module. First you have to module properties. In this, execution, displays and tool, where whatever displays are required, then you have to name it. So analog input monitor with the alarms. This is your description. Then setting up properties of the module, primary control, detail, faceplate required or not. So entire thing you have to mention, and scan rate you have to mention. So selecting displays, there are various display screens available, and you just select it. AI display, AI faceplate, and you can see on the graphics these are the faceplates. So moment you click on LIC, you'll get a detailed faceplates. Enter the name of the module, enter the name of the wireless, and you see this is the faceplate you will come, because you have selected, and you will get this value 27.1 here also. So this is a faceplate of one of the device tag, value, scale graphically, and toolbar here. I'm talking about this. Moment click it on this like this. So I think this is what entire system is configured. Graphic development, entire graphics faceplates are already prepared. Only you have to link it and enter your specific parameters. So that is what about this displays, and that's ends. Thank you, madam. Hello. Hello.
Yes, sir. Yes, sir. Thank you very
Thank
much
you,
for
thank you,
sharing
thank you.
your valuable knowledge regarding Emerson Delta V. We will
Okay,
meet tomorrow again with the new DCS system.
okay,
Okay,
got it.
another one. Which
Okay.
is comfortable, sir? Yokogawa, we will start tomorrow.
Yeah, that no problem. Yokogawa you can,
Okay,
or
okay, sir.
Honeywell.
Okay,
You
time I
choose.
will share with you.
Okay, thank you,
Okay,
madam.
thank
Thank
you.
you.
Thank you very much.
Thank you. Thank you.